All right, so when naming organic compounds, the compounds are named based on the prefix. So the compounds are named based on the number of carbon atoms and the functional group that is present in the compound. All right. So the number of carbon atoms tells the prefix that we assign to the name, and the functional group tells us of the suffix or the ending of the name. So if there's one carbon present, only one negative carbon, then the prefix is meth. 2, F, 3, prop, and you can follow the line, come down all the way to 10. All right. There can be a lot more, but we're going to stop at 10 for CSEC because you don't need to go past 10 for CSEC. All right. So the prefix of the name is based on the number of carbon atoms. The ending of the name is based on the functional group. So this is what we mean by functional group. The functional group is a type of bond or atom or group of atoms that give a compound its functional or its function, I should say, or it basically tells how something will react. All right. It basically is responsible for the chemical properties of that compound. So if there are only single bonds present, so carbon to carbon single bonds, then the compound is an alkane and the suffix is ane. If there is a carbon to carbon double bond present somewhere in the compound, then the substance is an alkene and the suffix is ene, ene. So it ends with ene. If there's a carbon to OH group present, so a hydroxyl group, so this OH that you're seeing here, then it is an alcohol and it ends with anol. And if there's a carboxylic functional group, so C double bond O, OH, or a COOH group present, then it's a carboxylic acid and it ends with anoic acid. So right down here. So let me put this. So right down here, we have something that has, let me highlight so you can see. So down here we have something that has 1, 2, 3, 4 carbon atoms. Because there are 4 carbon atoms, the prefix is BUT, bute. So that's why I see bute right here. And then we count or we look at what else is there. There are only single bonds between the carbon atoms, no other functional group, no other atom present aside from carbon and hydrogen, then that means that we're looking at an alkane because there's only carbon to carbon single bonds present, nothing else. So we're looking at an alkane, so it ends with ane. Following so far, Kasiana?
Yes, sir.
All right, let's go up here. Let me draw off my eraser. Let's go up here. So, spotlight. All right, let's go up here. We have, again, we have 1, 2, 3, 4 carbon atoms present. Because there are 4 carbon atoms present, the prefix is bute again, it's BUT. And then we look, we see an OH group present. Because an OH group is present, an oxygen and hydrogen bonded to a carbon, then it's an alcohol now, and it ends with anol. So we put the first part of the name BUT, bute, with the last part anol, we end up with butanol. We can see that, right? Yes, no? All right. I'm assuming that you're seeing since me not getting the answer, so I can't say. Casey, are you still here?
Yes, sir.
Are you understanding what is being shown?
Yes, sir.
All right. Right here we have something with 1, 2, 3 carbons. Because there are 3 carbons, the prefix is pro, P-R-O-P. So let me just go back really quickly. 3 carbons, the prefix is prop. So prop. And because it's a carbon to carbon double bond present in the compound or molecule, then it's an alkene, so it ends with ene. So alkene, because a carbon to carbon double bond is present. So the name of this now is propene. So put the prefix from the number of carbons with the suffix from the functional group. So carbon to carbon double bond, we end up with an alkene. So it ends with ene. Clear? All right. Okay, Sienna, I am going over this because of you. So you can at least answer so me know if you hear me or not. All right.
Yes. Yes, sir.
Okay. So you hear and understand what me I say?
Yes, sir.
And the last thing over here is an alkane. So carbon to carbon single bonds alone present. So it ends with ane. And because there are only two carbon atoms present, then it's an alkane. Again, two carbon atoms present, then the prefix is F-E-T-H. So the name is ethane. All right. So that's basically what we have been looking at. That's basically what we have been looking at. So really, really quickly, I'm going to draw something right here and you will just name it for me. What will be the name of this compound? Wherever you see just the dash, there's an H at the end. All right. So where you just see the bond, there's an H at the end. So what will be the name of this compound?
Pentanoic
Pentano.
acid.
Pentanoic acid. All right. So there are, let me change the color. So there are one, two, three, four, 5 carbons present. So the prefix is pent. And the fact that we have a C-double-bond OH group, then the ending is anoic acid. All right. So that would be that. All right. So I assume everybody understand what just got on a while ago?
Yes, sir.
Lovely. All right. Nope. You go right there. All right. So I'm not going to go through one more example or any more examples as yet. I'm just going to turn over to um the PowerPoint. I'm going to all right, so let me start sharing something else. Share this thing right here. Are you seeing my screen? Let me know what you're seeing, if you're seeing anything. Are you seeing my screen?
PowerPoint.
You're
Yes,
seeing-
sir.
Okay, good. All right, so we're looking at a homologous series is a group or family of organic compounds that has the following characteristics. They have the same general formula. They show similar chemical properties because they have the same functional group. Each member differs from the previous one by CH2. They show a gradual change in density, viscosity, flammability, melting point, and boiling point. I believe we actually started looking at this before. I'm going to be sending out a video on structural isomerism. So we're not going to go through that now because I think we did that earlier as well. So we're looking at alkanes and we're looking at reactions of alkanes. So first thing to note, ladies and gentlemen, all organic compounds undergo this reaction here, combustion. All right. Every single organic compound can undergo combustion to some extent. All right. So when organic compounds undergo combustion, then the organic compounds undergo combustion. What we have happening is that carbon dioxide and water is formed. So alkanes undergo combustion in air or oxygen. So they burn in air or oxygen to form carbon dioxide and water vapor. So carbon dioxide and water is formed, but it is vapor because if something is burning, more than likely the water is going to evaporate. So that's why we end up with water vapor. All right. So every single time we have combustion taking place, these are our products, carbon dioxide and water. Regardless of what is burning, our product will be carbon dioxide and water. Everybody clear on that?
Yes, sir.
All right, so we have two things here. We have methane, so an alkane with one carbon and four hydrogens, that's methane. And here we have ethane, so an alkane with two carbons. So again, as long as you know the number of carbons, you can know which alkane or which organic compound you're dealing with, so you can probably name it based on that. All right, so CH4, so methane plus oxygen gas, will react to form carbon dioxide and water. And the only thing that we need to do is balance the equation, because again, as long as you have combustion taking place, the products are carbon dioxide and water. And then we have ethane, C2H6, reacting to form carbon dioxide and water when it burns in oxygen. So this is combustion. There's nothing more to it. Alkanes undergo combustion in air, so they burn in air or oxygen gas to form carbon dioxide and water vapor. All right, so that is the first reaction of alkanes. All right, it is to be noted that alkanes are not very reactive. So alkanes are not very reactive. So they don't undergo much reactions or many reactions. There are only two reactions of alkanes that we'll be looking at because alkanes are not very reactive. This is the first one, which is combustion. And then the second reaction that alkanes undergo would be substitution reactions. All right, so first reaction, alkanes undergo combustion to form carbon dioxide and water. And the second, alkanes will undergo substitution. Alkanes will undergo substitution with halogens. All right, so we're going to, where's my whiteboard? All right. Right, so alkanes react with halogens such as fluorine, chlorine, and bromine under UV light or heat to form a mixture of halogenoalkanes or haloalkanes. All right,